Okay, clearly this question will involve the use of this formula, power is equals to F times V. So let's see how we can apply this. So in the first situation here, the speedboat is going at constant speed. That means that the driving force provided by the engine, in fact two engines, must match the drag force experienced by the speedboat. So we were told that the drag force is proportional to the square of the speed. So we can write this as kv squared. And since the velocity we were told is 12, so we can write it as 12 squared. Okay, so the speedboat at this stage was operating with two engines, so the total power would be 72,000 watt. So power is equals to the driving force, but because it's going at constant speed, right, so we know the driving force is equal in magnitude to the drag force. So the driving force is actually k 12 squared times the velocity a, which is 12. Alright, so now we go to the second situation when the boat was operating with only one engine. So only one engine, so the power drops to 36,000 watts. With one less engine, obviously it's not going to achieve the same speed as before, so the drag force will be smaller, and we will write the drag force as kv squared. So the v is the new maximum speed. The maximum speed is again achieved when the drag force is just able to overcome the drag force. The driving force just overcomes the drag force. So now let's go back to P is equals to F times V. So this is the power. The driving force is now kv squared. We'll just write it as kv squared. And the V here is of course V. Alright, so you got two equations here. The obvious thing to do is to take one divided by the other. Alright, so you eliminate K and then you can solve V. You should be able to get the answer, 9.5 meter per second. So what you have to do, apply this formula to the two situations and bring in the information that the drag force is proportional to the square of the speed. That's it. Ta-ta!